A very good evening to all of you. Today the lecture is Spatial Database Management System, Post-GRE SQL and Post-GIS. To begin with, I will just highlight what will we cover today in the lecture. First of all, we will go for the introduction part, then definition and classification of the spatial database system, evaluation of the spatial database processing, introduction to PostgreSQL and PostGIS, spatial data, what is spatial data actually in PostGIS, PostGRE SQL and PostGIS, what are spatial queries using PostGIS, how to fire a query using PostGIS, visualization of the queries in QGIS. So this is the outline of the lecture. So just to begin with, the volume of the spatial data available for processing increases rapidly over the years with the evolution of sensing devices and telecommunication technologies. Most of the data that can be stored and analyzed carries spatial information. Hope all of you may be aware of what is a spatial component of any data. When we talk about the spatial data, that means some locational information attached to the data, like where is it, at what coordinate system it is available. So now most of the data that is stored and analyzed carry the spatial information, and as a result the management of location and geometric features of entity is essential component of modern database management system. Spatial database management system manages large collection of spatial data which are apart from conventional features. It also includes spatial characteristics such as geometric positions and extents. Now, according to Gutting, he defined the spatial database, as a class of database system that have the following three characteristics. A spatial database system is also like any other normal database system, but it also offers spatial data types in its data models and query languages. It supports spatial data types in its implementation, providing at least spatial indexing and efficient algorithms for spatial joins. We will be covering what do you mean by spatial indexing and spatial join in the subsequent slides. Gutting, in his definition, considered spatial data only as underlying technology for GIS. Whenever we talk about GIS, so this spatial data comes into picture, because GIS is a separate system for which spatial data act as an input. So we can say spatial database systems are by no means fully operational GIS, but only facilitates a small subset of the functions that a GIS can provide. Now, evaluation of the spatial data processing. In the conventional data processing for GIS before mid-90s, it used to have some spatial files that are called the flat files or the data files. These files were provided to the GIS tools and data engine as a software tool, we can say over here, and this goes directly to the GIS application. There are many GIS applications. It can be any kind of mapping, it can be a site suitability analysis, some modeling. So all these geospatial applications, they used to take their methods or the procedures from GIS tools, and these GIS tools used to take the data from the data files which were stored as a flat files. Correct. After this 90s, in the late 90s, the concept of RDBMS, the Relational Database Management System, came into picture. Means non-spatial data was getting stored into the RDBMS, and our GIS data engine, this was the middleware between the RDBMS and GIS tools. It used to collect the non-spatial data from here and provide as an input to the GIS tools. GIS tool further used to analyze it or do certain kinds of processing for these GIS applications. That was the case in the late 90s. But in the today's environment, we have it like the GIS data engine is there. There are extended SQL, means our data is also stored in RDBMS in the form of RDBMS, where it stores geometries also as well as the procedures. These procedures are fed to the GIS data engine, which gives it to the GIS tools, and then further it goes for the GIS application. But here one additional is over here, like we can have a data warehouse also.
Data warehouse means a collection of large number of data sets. It can be the database can be from multiple sources. So this warehouse contains all sorts of data, and it also have extended SQL queries which are stored over here, and these can be provided as an input to the spatial applications. If we talk about GIS and SDBMS, SDBMS means Spatial Database Management System. Now, what is the difference between GIS and this SDBMS? Geographic Information System, what are the primary tasks? It collects the data. It also offers for editing of the data. Data analysis is provided over here, and generation of maps and cartographic information products. Whereas in case of spatial database system, it facilitates for data storage and management. It facilitates spatial indexing. It also provides data security and integrity and spatial queries also to fetch the desired information from the stored database. So this is the basic difference between GIS and spatial database system. This spatial database system acts only as an input for this GIS. Further, this diagrammatically, this can be explained over here like we have a geographical information system, and I have some spatial database management system. This is one software, and there is one data, spatial, non-spatial, all kind of data is stored over here. Then over on the top of this data, I have a management system. This management system manages the entire data set over here. It stores it here, it fetches the data from here, keeps with it, and then further provide it as an input to the geographical information system. The tasks for GIS are data loading, editing, visualization, mapping, analysis. Whereas in the case of this spatial database management system, it includes storage of the data, indexing, security, and query. Further, spatial database must integrate with other applications and data also. Means this is some spatial data. Then this is that internet layer is over here. I can have a GIS desktop application. I can have a web-based application. I can have a mobile applications also, or some custom application which is a mix of different kinds of applications. So for that, I have some server-side applications. Means I will develop the code at the server end, which will fetch the data from spatial data and map renderer. It will provide it to the internet. From internet, these are provided to the various applications. Next, if we talk, what are the basic operators? Like spatial reference. It is one of the operator for spatial database management system. Envelope, export, is empty, is simple, or boundary. These are the basic operators of a spatial database management system. The functions contained in these basic operators includes reference system, like what is the projection system of the spatial data. This envelope means what is the bounding box of the geometry. Export, suppose I want to export the data to some different representation or to different formats. Test if the geometry is empty or not. Return if the geometry is simple. Return true or false if the geometry is simple or not. Boundary returns the boundary of the geometry. Similarly, I have some topological operations also. So after the basic operation, we should have the knowledge of topological operators also. What do we mean by topological operator? Means the relationship operators between different features like equal to, whether two spatial entities are equal or not, they are disjoint or not, whether they are intersecting with each other or not, whether they touch each other, whether they cross each other, whether they are within each other, or they contain, whether the other one is contained within the another geometry, or it overlaps the geometry, or relate, that is the intersection matrix holds. Once this topological operator means these are the operators which are dealing with the neighborhood and spatial entities, like two neighborhood entities are there, spatial entity number 1, entity number 2, how they are sharing some operations among themselves. After that, we have some spatial analysis operators also.
like distance operator. Like the functions will be the returns the shortest distance between any 2 points between two given geometries. Buffer zone. Suppose I want to return a geometry that represents all the points whose distance from a given geometry is less than or equal to a specified distance. In the case of example, let us take, suppose I want to have a buffer around the road of a city, around 100-meter buffer around the road of the city for any particular application. Like suppose I want that there should not be any kind of constructions within 100 meters of road on both the sides of the road. So we can use this kind of buffer applications over there. Similarly, I have intersection operators, that again comes in the category of spatial analysis. I have union operators also, difference operators also, and sim difference operations also return the symmetric difference, the logical XOR of two geometries. So these are the spatial operators. These have some topological operators and some basic operators. We should have a proper knowledge of all the functions available with spatial database management system. Next, why use a database for GIS? That is the big question over here now. GIS are not the database system, but it is actually a system of some connected components. Already it might have been covered in your earlier classes also. Although they can be connected to a DBMS, but the question is why to connect database for GIS? A GIS cannot efficiently manage large quantity of non-spatial data at department level or sometime at the government level also or the country level also. That data it cannot efficiently manage. They lack ad hoc querying capabilities. They provide a restricted form of predefined queries. They lack indexing structure. Indexing is for searching of the data. It will take a lot of time for searching the data. If I am storing the data as a flat file, not in the database management system. Flat file is just the opposite of the database. Means I am keeping the data as a file only. Whereas in case of database, I will be storing the data in tables, which allows a lot many features, which I will explain in the next slides. Okay, in the coming slides. Now, if you see here, these are some of the very important functions or very important properties of a database. The data is reliable. Integrity, it enforces consistency, means the data is consistent throughout the system. It provides security, means it is not like selecting the data and deleting it. So there are some security mechanisms that can be applied to the spatial data. These are true for any kind of database, whether it is a normal RDBMS or it is an SDBMS, Spatial Database Management System. It also facilitates user view, user interfaces, querying is available, updating the data. DB theory has a database theory has a mathematical basis also. Data independence, it allows data independence, data abstraction, self-describing, concurrency is there, distributed capabilities, high performance. Suppose it also supports spatial data types, like using the ADT. ADT means abstract data types. Whereas these features are not available with the basic file system. So these are the very important, or we can say very necessary features which should be there for any kind of data. So now here, why you like spatial querying using the SQL? Use simple SQL expression to determine the spatial information like distance, adjacency, containment. Use simple SQL expression to form spatial operations, area, length, intersection, union, and buffer. These all can be executed. These are the features which are available for any kind of spatial database. Because I need to calculate distances also. I need to know the adjacency of two features. I need to know the containment. So all these things can be performed with the help of SQL expressions also. SQL means SQL query language. So these operations can be very efficiently, or I can say I can perform this task at a very quick speed also with the help of SQL expression. Now here we just one figure example we have given it, like in SQL query. Suppose I want to know the distance, like where this is the kind of function. This is a syntax, a sample of the syntax. Like I can just write it the where clause, distance, mean, then hospital location is less than 1000 meters. Means I want to find out the distance of the hospitals near to near or less than 1000 meters from my location. Now, where clause, the inside containment, inside is a containment operator. Hospital locality, city area, and city name. So here I can fire, suppose let us say any city, Delhi, here, and city area and hospital location. What are the where are the hospitals which are located in this city? Name New Delhi. So these kind of queries can be fired with the help of SQL statements also. Now here, what is a spatial database? Just I will recap it. Just try to recall it. Okay, whatever we have understood till now. Database that stores spatial objects. Spatial object means an object which contains location information also in the form of the coordinates of the ground coordinates. Like suppose a house is there, so I need to know where is that house and what that house contains. So the concept of where is that house, that is the spatial content of that object. Similarly, a database that manipulates the spatial object like any other objects in the database, it is also known as a spatial database. So this spatial database management system provides us the facility for storing the spatial object, for manipulating the spatial objects like any other database in any other objects in the database. There are three aspects of this spatial database management system. Spatial data types. Spatial data types means it can be a line, it can be a point, it can be a polygon, spatial indexing, and spatial functions. Now, what are the spatial? Who are the vendors or we are the players who provide this spatial database management system? From ISRI, we have Arc SDE, we have Oracle Spatial, IBM DB2, along with Spatial Extender, MySQL Server. It also offers the spatial database capability. SAP, SysBase, SQL Anywhere, MySQL Spatial, PostGIS. So, for the sake of this lecture, we will be covering this PostGIS because PostGIS and PostGIS SQL is a very well known or popular spatial database management system. Now, let us have a recap of these data types also of the standard database and a spatial database. In the standard database, we have the data types called varchar is there. Varchar means it is a mixture of characters as well as numbers. Integers are there, only the integers. Real means decimal numbers also there. And a data type called date. Whereas for the case of spatial databases, we have points. It can be a line string. It can be a polygon. Multi-point means a collection of points. Multi-lines means a collection of different disjoint lines. Multi-polygons means a collection of disjoint polygons. So we can have different types of spatial data types also in case of spatial database management system. Now here the functions. Let us talk about the previous slide was the variables or the data types. Now the next is coming of the functions. Like normal database has the functions is lower, round, substring, trim, date of the week. These are the basic operators or the functions of a standard database. But when we talk about the spatial database, I have the functions like st underscore area. Then here I have to define the geometry. Suppose I want a area of the polygon. So st underscore. So there is a slight difference in the SQL queries also. Like we can have it st underscore distance also. For distance means two geometries. There are two parameters to it: geometry and geometry 1 and geometry 2. St intersect, again two geometries are there. Where it intersects with this geometry and how it intersects with the other geometry. St underscore d within, distance within geometry and then radius. Whether this geometry lies within this given radius of this geometry or not. So these are different kinds of functions that are available with spatial database management system. So one example. This is some database queries. Is there a main street? How many patients does the health center serve? How many buildings in the city have more than 2 stories? What is the actual amount of cash withdrawn from customer X? These are some database queries, not the spatial. Is there a main street? So I have a table where a attribute is there called streets, and the values it will be having main street or the local street, like that way. So there I can fire these types of queries. So it will give me the results of, in case of yes and no, how many patients, that count function will give me how many patients are there, how many buildings are there, what is the total amount of cash withdrawn from customer X. So these are the normal database queries. Whereas if we talk about spatial queries, it can be like this. What is the total length of main street? I don't want number or some logical operator, yes and no, but I want the length of the street. So the queries will be what is the total length of the string, how to calculate it through spatial database management system, that we will cover later on. Now, but before we should understand what type of queries are there which can be fired on a spatial database. What is the total number of patients within 3 miles of the perinatal perinatal center? Means I want not only the numbers but also the number within a certain distance. So this distance parameter, it will be through some spatial queries only. Now just see the other one also. How many buildings of more than 2 stories are along a parade route? So I have a parade route. I am interested in knowing the number of stories along that route only. Have all the cash withdrawal for customer X been within 50 miles of their primary residence? So some buffer kind of queries over here. So these are the different kinds of special queries that can be solved or that can be executed with the help of a spatial database management system like PostgreSQL. PostgreSQL. Now let us, there are, I already told you also that there are many offerings for spatial database management system. PostgreSQL is an open source. It also a very powerful database management system. It has more than 15 years of active development and proven architecture that has earned it a strong reputation for reliability, data integrity, and correctness. Now, another important thing, it runs on all the major operating systems. It is a fully ACID compliant and has full support for foreign. ACID means abstract is there, consistency is there, integrity is there, and dependency is there. Joins, view, triggers, and stored procedure. It has a native programming interfaces for C, C++, Java, Net, Perl, Python, Ruby. Means I can have this spatial, this PostgreSQL spatial database in management system connected to any kind of programming languages also. Means I need to just connect through a programming interface. I will write a few lines of code, and this database get connected to my programming interface, and there I can manipulate or I can perform any kind of operation with that programming language also. It has some exceptional documentation also is available online. Now there are some active Postgres system in the production environment that manages 4 terabyte of data. Means how much data it can store now? We can say maximum database size is unlimited. You can store unlimited size of the data in a PostgreSQL database. Maximum table size is 32 terabytes. Maximum row size is 1.6 terabytes. Maximum field size 1 GB. So these are some of the some architectural features of this PostgreSQL. The current stable version is 9.4.5 of PostgreSQL. Now, PostgreSQL I told you earlier. Now, what is PostGIS? But there are two terms I am using continuously. One was PostgreSQL and the other one is PostGIS. So if I talk about PostGIS, PostGIS is a spatial database extender. Means we can say an extension for PostgreSQL. PostgreSQL is a normal object relational database management system. But this PostGIS is an extension of this PostgreSQL. PostgreSQL is normal database management system. PostGIS is a spatial extension to it. Means all the spatial related information is handled by this PostGIS extension of PostgreSQL. It adds support for geographical objects, allowing location queries to be run in an SQL. Like let us say one SQL query. Select superhero.name from city superhero where this st underscore contains. This is a function which is available for in PostGIS. It is not available in any kind of standard database management system, but it is available through PostGIS only. So here I am writing city.geom means geometry of the city, superhero.geom geometry of the superhero, and city.name equal to Gotham means this is the name, this is the non-spatial kind of thing, and this is the spatial entity of this query. A normal SQL query, it has a spatial entity, it has a non-spatial entity, both it is having. The current version of PostGIS is 2.2.0. This is also open source, as it is available with PostGIS. PostGIS, since PostGIS SQL is open source, so PostGIS is also open source. Next, if I see PostGIS, let us talk something about PostGIS also. Now, it implements and is compliant with OGC, Open Geospatial Consortium. This is one international organization which is responsible for the standardization of spatial data. Standards are required for each and every kind of data. So, an international body called OGC, similar to ISO. ISO, all of you might be knowing it. That is an international organization for standard. So for the spatial database, we have OGC. So PostGIS also follows all the OGC simple features for SQL standard. It also supports all the OGC types like point, line, polygon, multi-line, multi-polygon, geometry collections, and other operations. It also, this PostGIS uses OGC well-known text format on the SQL command line to represent the GIS feature. Let us take this example, point 1, 1. This is one spatial entity. Line feature, 1 space 1, then second node, and this is that third node. For each and every node, I have two coordinates, X coordinate and Y coordinate. Similarly, for polygon, I have a closed. This is 0, 0 is the initial polygon, and at the end, I have this 0, 0, the ending node. So a polygon is formed over here. Suppose it also adds extra types like geometry is there, geography is there. We will later on come into the what is the difference between geometry and geography. Raster is also there, and some other features also there. It also adds functions, operators, and index enhancement that can apply to these spatial data types. Now, okay, this was about PostGIS SQL and PostGIS. Now let us see how to get this PostGIS SQL or PostGIS installed into any computer. We can just, for the Windows platform, let us talk about a Windows platform. We can download it from this URL http://www.postgresql.org download Windows. So it is available in both the features. 32-bit is also available there. 64-bit installer is also there. So you can just download from this link. Once it is downloaded, you can store it into any location of your computer. There are other options also, like Enterprise DB. This is also one player which provides the download of this PostGIS SQL along with PostGIS. It also runs a stack builder utility and installs some other features also apart from PostGIS. Download and install the appropriate PostGIS installer for your PostGIS version from the PostGIS window download site. OpenGeoSuite is also one area from where one web link from where we can get this PostGIS and PostGIS installed into our computer. This is a stack of some software. Now this when double click the downloaded file, the installer, it will start it. Then it will ask for the location of the installation. Location for this directory and some username and password for the administrative privileges. Then it will ask for the port name. Usually some default port name is displayed over here. You can just take that port itself because a port is required for database connectivity also. This will be requiring in your when you try to connect your database with some programming interface. So these ports are required at that time. Similarly, it will say for installation of some other files also. And once just click just next to this slide, and it gets installed into your computer. Once it is installed, next the case will be installation of the PostGIS. Same PostGIS here I have downloaded. Just run it. It will ask for the license agreement. Then it will ask for the creation of a spatial database template. The template is created which you can use for creating any other spatial database when using the PostGIS SQL. Location of the PostGIS installation. Then it will search for the PostGIS SQL because it requires PostGIS SQL. Then it will ask for that same username and password which we have given in during the installation of PostgreSQL SQL. That same password and username user and password should be given over here. This is an optional item. Then it will start installing PostgreSQL,
and this PostGIS gets installed and integrated into the PostgreSQL. So once that PostgreSQL is installed, now PostgreSQL has a number of administrative front end, means how to access it, although it gets installed. So I can access to the PostgreSQL through a command line interface also, that is PSQL. Just go to the command prompt and type PSQL, PostgreSQL will install. The other option is pgadmin. So this is a user friendly. It provides us the interface where I can just see which all databases are installed in the computer, and and it also allows for the firing the queries, for creating a new database table, importing the tables from other sources also. All the features are available in this pgadmin. So I advise we can use pgadmin for further processing of your PostgreSQL. Now here, once you start the pgadmin, this window will appear over here. In this window, here you can just see one PostgreSQL, one sample database is already available over here. So what we can do, right click on the database item and select a new database. Next screen I will go. Now here, PostGIS is the name of the server, localhost, some 5432 port is also defined over here. So here I have the database, right click here, new database, give a name to the database, and database is created. Now, once the database is created, that is a normal PostgreSQL database. That is not having any kind of special feature into it. It is a standard database only. So, in order to have a spatial extension or this PostGIS functionality into my database, I need to follow a small step. Like select the new PostGIS demo. This is the name of the, like, let us go to previous slide. Here the name of the PostGIS demo. This was the name of the database which we have created just now. So PostGIS, select the, it will be displayed over here, PostGIS demo. You select the new PostGIS demo database and open it to display the three objects. Public schema is present there, three objects, catalog, extension and schema. Three objects are available with this PostGIS demo. Click on the SQL query button or go to the tools. Tools is also there. We can just go to backslide here, tools or SQL query button. Select this tool and then we can fire the queries also. So there are two queries that we have to fire. The first one is create extension PostGIS. Click the play button in the toolbar. In the toolbar, that play button will be over there. You can click onto that. So this query will be fired. Then select PostGIS underscore full underscore version. These two, PostGIS and PostGIS full underscore version, these are the procedures that are available with PostGIS. Once we fire it, this spatial extension will be added to our PostGIS demo database. Here we can just see earlier in the previous slide, we can see there are no tables available with this database PostGIS demo. There are no tables, but once I fired these two queries, so there is one table created in my database PostGIS demo schema, and I have some table here. Then spatial underscore reference underscore system. This is one table that has been created in my database. This table is responsible for all kind of reference systems, coordinate system for the projection system. This will provide it. This will provide the reference system for my various kinds of data. Now let us talk about, there are two types of PostGIS entities. One is geography and other one is geometry. This geography is the latest addition to this PostGIS. Earlier we used to have only the geometry type, but now a new extension that is called geography that has also been added to PostGIS. Data in geography data type, it is always stored in WGS84 GCS, that is geographical coordinate system, i.e. that is latitude and longitude degree. In this projection system only for this geography data type. And whenever we are making the calculation, they are expressed in meters only. It automatically calculates it in terms of meters. Geometry data type, it can be stored in any reference system. So this is the major difference. Geography type always in GCS, whereas geometry in any kind of spatial reference system. This arrangement has been only made to make some measurement accurate, because this GCS it take care of this curvilinear nature of the earth.
Whereas in case of Cartesian coordinate system, which this geometry type supports, there an approximation of all those curvilinear features have been made in different kind of projection systems. So a little bit of mismatch is there in the measurement. So whenever we need to make a measurement at a very large scale, then we can go for geography. Whereas if you have to make the measurements at a very local scale, then we can go for this geometry data type. It can meet the measurements in units of spatial reference system for the geometry type. But whatever reference system we have given, the same will be the unit for this geometry data type. If your data is geographically compact, means it is contained within a state or a country or a city, we can use geometry type with any Cartesian projection based on your data. It can be a UTM, it can be LCC or polyconic, any data, any projection system can be used for in case of this geometry data type. Whereas, if you need to measure the distances within a data set that is geographically dispersed, covering much of the world, we have to use geography data type. So these are the two data types, geography and geometry. Large scale, so we can, large scale means it covers a larger area. Then we can go for geography data type. Whereas if it goes for the local scale or the local area, then we can go for geometry data type for any kind of measurement. Now, as we have seen earlier also, there was one table called spatial underscore reference underscore system. This is the table which contains the spatial reference system. It has the information of all the available reference systems, UTM, GCS, any reference system, the information is available in this table. And when I am making a table, it gets the reference from this table only. The data gets the reference from this table only. It reads from here. The geometry column, it is a read-only view listing actual spatial feature, geometry column and geometry types present in the database. Geography again similar to geometry only, but the only thing is the values are in the form of latitudes and longitudes only in case of geography, whereas in case of geometry it can be in terms of the we can say in terms of the units of the reference system. It can be a meter, it can be a degree, anything. Whereas in case of geography, the features will always be in terms of degrees only. Now, one example here. Now, spatial reference data, how to create it actually. I can have it create table spatial, one small query we are firing here, SRID integer. Like for GCS, we have 4326, not null, primary key, author name, varchar, author SRID integer, SR text, varchar 2048, or and projection for text, varchar again. So these are the, if you see, if you just open your reference table, so you will be finding these are the field name in your table. SRID may be there, author name may be there, author SID, SRTXT or project TXT. These are the columns or these are the fields that are available in this spatial underscore reference underscore table. And whereas when we are firing that query, previous slide, let us go. This query, like create extension PostgIS and select PostgIS full underscore version. So what it was doing, it was in the background, it was firing this query only. It was creating a table called spatial underscore reference underscore system with these table name, this column name, this field name. Now, let me skip. This is also same time of geometry only. I will skip it. Let us go to some other. Now, what are the functions? Let us say what are the PostgIS functions that are available. Single geometry. As these are the functions or the procedures, okay, which we apply over the database. St underscore length geometry. It is a line feature. So it will give me the length of the geometry, of the length of the line. If it is a point, length will be 0. I have data type is float only. This is st underscore area. So you can just see we are putting one small prefix called st underscore. So this is the unique, this is the feature which this PostgIS applies. Here I can put this prefix and my all my PostgIS functions are with this prefix only. Geometry st underscore buffer. Text xt underscore text geometry. Similarly for multiple geometries, this was single geometry means single feature is there. Multiple geometry means there are multiple features. 2 lines are there, 3 lines, 4 lines, or 2 polygons, 3 polygons. Points also, many points are there, or a line and a polygon, or a line and a point. point and polygon. There are multiple geometries. So the functions available for geometry, for multiple geometry include distance from one geometry to another geometry, or from one line to another line, or from a point to a line, or from polygon to a line, point to a line. So these functions like boolean st touches, it will give me a result in form of x true or false, whether this point touches this line or not, whether this line touches the polygon or not, intersects, same way, like disjoint also, and intersections for it will, what here it will do, intersection, it will perform the intersection of two geometries and it will give me an output as a geometry only, not as a true and false, but as a intersection of the two geometries will be provided. So these are some of the functions which are available with PostgIS. Now I have some let us say creating a geography table. Let us try to create one geography table also. We will have a better understanding out of it only. Like create table global underscore points, name of the table. Then I have one field called ID. It is a serial, means automatic numbers will be as I add the attributes, as I add the values to it, though it will have a serial number also. 1, 2, 3, 4, 5, as any number of features I have it. And we are saying that this is a primary key. Then I have another attribute or the field name called name. The type is varchar 64. Then I have one third field called location, which is a geography point comma 4326. This is the reference system for GCS. I told you earlier also, if I am creating geography, then it should have GCS only. So this is the table which will create, this is the query which will create a table by the name global underscore points. It has fields 1, 2, 3. 3 fields are there. Now register in the geometry underscore column view. So here I will see how to insert the values into it now. Insert into global underscore point. This is already created. Then I will write the first name is because this ID is automatic, so it will automatically take the first value, value 1. So I need not to specify it over here. I will have the name. The other is location. What are the values for it? First is town. Another is st underscore geography from text. So I am giving a text over here. What is that text? SRID equal to 4326 comma point. This is the latitude and longitude of this location. So similarly I will add another point and one more point. So 3 points are added. So the syntax is like this only. Create the table here, then insert into name of the fields and then values. Values for geography it will be given like this, geography from text, because this is one text string. It will convert this text string into a geometry type or a geography type, we can say, to be more specific. Once I fire those two queries, then I have to fetch those features also. Select name, location from global underscore point. So what it will do, it will give me the values like this: London, town and forest. 3 queries were there earlier. Name was town, forest and London. Okay. So these get stored into a table. The table is displayed like this: London, town and forest. These are some binary, some other format. It will not show exactly like that because this is not a value, but it is a geometry actually. I can fetch this also. There are some SQL queries which will allow me to fetch the coordinates also. Now similarly I want it like this: select name st underscore as text, not as this long string, as text, location from global point. So what it will do, it will fetch me the coordinates also. Point 0, 49, we can see previous 0, 49. So I got it, the coordinates also. In the table it will be stored like this, but if I want it in coordinate form, I have to fire this query st underscore as text. Directly if I say location, it will give me this one. If I want coordinate, then I have to fire st underscore as text. Now creating a table with spatial data is done in 2 stages. Now create a normal non-spatial table like create table rows underscore geom id int name varchar this way. Then add a special column to the table using the add geometry column function. Now by this function, this special query, I have created one normal table, any table. It has the feature called id. It is a feature that is integer type. Then I have another uh, field that is name, that is a varchar type, characters only. Now I need to convert this road road underscore geom table into a special table. Then I need to add one geometry column to it. So add a special column to the table using the add geometry column method or the function. Select add geometry column, schema name, table name. This is the syntax: column name, SRID, type, and dimensions. So the exact value will be like this: select add geometry. Schema is public because we have seen there also it was public only. Then name of the table is road underscore geom, comma, column name is geom only, the name of the geometry. Then SRID is 0, line string, it is a line string, and comma 2 dimensions. Or the other way also, load in save file and spatial table will be created automatically. You load this data in a save file and it will be created in the table itself. How to do that one? We will just see in the coming slides. I can have a save file also, and that save file get loaded directly as a table also. How to import it, that table also. Now, create a table, create a data upload file, rows.sql, and this insert this you can write in a normal text also. Insert into road underscore geom. This is the complete syntax of it. Value first st under geometry from text, line string. And now what in the previous step I have created one road underscore geom. I have added one column to it, geometry column, geom column. Now I am inserting data into it. So the same syntax is there. Insert into road underscore geom, name of the table, and these are the field names. ID was there, geom was there, and name was. Only 3 fields were there. So what are the values for it? ID is 1, st underscore geometry from text for the geom, line string, coordinates I have given over here, and name is Jeff road. Second road, third, three columns I have added. Then I need to fetch it. Select ID st underscore as text geom as geom name from road underscore geom. So this table will be fetched to me from the database table. Correct. So this way we can store the data in a table, and we can fetch it also using the select queries. Now let us say one more example here: how to convert non-spatial X and Y fields to PostgIS. Already existing some points are there. I need to convert them to a PostgIS or a spatial database. Let us create one table. Create table user underscore location is the name of the table. Correct. It has the field called GID, that is integer 4. Username is there, that is also varchar. So I have a table named user location with 2 fields, GID and username. Correct. Now I will add one geometry column to it. Add geometry column. Public is the schema. User location is the name of the table. The geom is the geometry column. Spatial reference, it is a point and 2 dimensions. Created. Now insert into the user location's value into the user location. This is the user location is the name of the table. Now here I can have it like this way also. Instead of writing in these field names directly, I can have values also. But I need to fetch. I need to give all the values over here. First is GID 1, location 1. Location 1 is the user name. Then st underscore geometry is this value for this the geo point, and it will create. Similarly, it will create a spatial point in that table. Similarly, this will also create another spatial point in the table. So I have add geometry column. This function add metadata information of this field to the geometry column, and drop geometry column, it removes it from there. Now, first we have to select both x and y coordinates into one field of the character type, like obj geom equal to 78. This is some values. Okay. Now then call the function geometry from text here. Let us go back.
here I was saying geometry from text st, we have to put this prefix st, okay. Now these two values are there, 71 and 48. So this is that function which is converting these non-spatial values to a PostGIS spatial point, correct. So the same thing I am writing it over here. Then we have to call the function called geometry from text and add the geometry type in the brackets, append the EPSG code, that reference system 4326, and then it will get added to your, then the points get converted to a spatial point or the geometry, or geography point or a geometry point. Next slide. Now loading a save file. That was suppose I was having some value and I need to create a PostGIS table or a spatial table. So one table was created, some fields were added, and then from the normal XY value, I have using the st underscore geometry from text function, those were converted into a spatial type. The table converted into a spatial type only. Now suppose I have the data not like this way. I have already I have collected the data in the form of a save file. Means save file already you might have learned in your previous classes also ki that is also a format of spatial data storage. So I have all my data in a save file. So how to convert that save file to a PostGIS table now? Save file is a flat file which contains the spatial data. Now I need to convert that spatial file, that save file into a PostGIS table. So for that, some functions are there. Save SHP to PGSQL, save file, table name, file.sql. This will be the name of that table, correct. Now example is here, SHP to PGSQL minus S, the spatial reference is there, name of the save file is there, and this church table name, and then churches.sql is the last file name which will be created. I need to have these two files, churches.shp and churches.sql. Read in.shp file, write out.sql file. So once this file is created, churches.sql, now load this SQL file into PostgreSQL using the psql command or using pgadmin also. See, this can be done with the help of pgadmin also. We have a save file loader also directly over there. Instead of writing all this command, I can have a save file loader also in this PostGIS admin, pgadmin. So this pgadmin allows me a user interface where it will ask for a, instead of writing this command, I am just telling you, it will ask for the save file and for the output table. So your save file will be converted directly to the table. So for this commands we can have a user interface also. Like PGSQL, okay, D is for the PostGIS, U is for Postgres, F, BC. Now this is one example we have given over here, like PGSQL to SHP, the reverse process now. Minus F test.shp, minus U Postgres, minus P 5432, minus U password, database schema, table. So it will convert a database table to a save file also. So both the way we have the functionality of converting a save file to a database table or a database table to a PostGIS or to database table to a save file also. Functions are available there. I will just skip it. Not required here. Now here, which I was telling you, that save file loader. So the interface compose GIS save file import export manager. So this is a save file loader. It will ask for view the connection details. So here I can write the PostGIS. What is the username? What is the password name? Localhost and 543 the port name and which database I want, where I want to get connected. Once I click OK, it will list me. Now it will list it, a blank list will be available over here. Now here I can have add files. I can add save files into it. So whichever save file I want to convert to a table or to a particular table of a database. So those save files need to be added over here. Then import. Those save files will be imported. At the background, it is running those commands only, which I was telling earlier also. So instead of going into the detail of those commands, directly we can use a save file loader also. It will convert all my save files to a database table. That is also freely available along with PostGIS. Now, once what we were seeing in the previous slide, like tables were there,
and some queries are there. So what contains the table contains all sorts of databases. Queries is a mechanism from which we were trying to fetch the tables, fetch the values of the tables. So the output was in the form of a table only. But in case of spatial database, I don't, we are not interested in seeing the values in the form of a table. Rather, we want to see the values as a map or as a spatially distributed points, lines or polygons, not as a table. Because table I can get it from any kind of database management system. But I need to go get, I want to read the geometry, actual geometry. Where is it in the map? So for that, how to see it now? So for that, QGIS, and again an open source software which gives us the provision of using those tables also. It will, what it will do, it will fetch those tables from the database and it will display them not as a table but as a locations. We will just see it over here how to get that one. This QGIS, it has those features also. So for that we have to go to this layer, new PostgIS layer. One option will be there inside this layer option. Add a PostgIS layer. Once we click the PostgIS layer, it will ask me to make a connection to the database, because you cannot directly connect to the database. This is a security feature over here, which was not there in case of save file. But here I cannot connect it directly. I need to provide the usernames and password. So once that username and password is provided, and then we can say connect. So if the username and password are correct, then only the table will be connected in this interface. Once it is connected, it will be listed over there and can be displayed. So what are the other viewing the data in other options for it? That is UDIG is there, QGIS already I told you. GVSig is also another option which allows us to view the tables as a spatial data, not as a non-spatial but as a spatial data. Web-based applications are there, Map Guide is there, Map Server is there, Geo Server. These are the web-based application program which help us in displaying the tables in a spatial form. These are the desktop-based applications which help us in viewing the data in a desktop environment as a spatial data. PG admin, already I have told you this one, so I will just skip it. Let's go to the next one. Some queries over here. There are 4 verbs for any kind of SQL. Select is there, insert, update and delete. These are the 4 verbs of any database. Select, it returns the row in response to a query. Insert, it adds new row to the table. Update, it changes the existing row in the table. Delete, it removes the rows from a table. Example, let us take some new examples also. So here the example in this section will make use of the 2 tables. There are 2 tables now. The first table is BC_road. It has one GID is there, ID or one name is there, and I have another column called geom. Okay, we can just see GID is integer, name is a character, or it is character varying, or the row, we can say a varchar kind of data type. Geom is a geometry kind of data type. It is having a location geometry. It is a line string. Then I have name is road name only, unique ID. Another table is BC_municipality. So I have 2 tables now. First is BC_road. The other one is BC_municipality. BC_municipality contains the field called GID, code, name, and the geo. So these are the 4 fields in BC_municipality. So just remember it. GID, name, important to us, and this is the geometry that will be fetched from some queries only. So GID and name are the 2 important things. Here GID is there, again GID is there in the municipality. We have one code and we have one name also. So one extra is there, code. So these 2 tables, we will be doing some queries also into it. Once we go to this PostgIS table, which was a table we have created earlier, PostgIS demo. Once you click it, then this SQL button will be highlighted over here. You just click this SQL, this interface will be visible to you. This SQL interface. Then here in this SQL interface, we can type the query. The first query, select star from BC_municipality. I told you BC_municipality was one table available with us. So one query we have fired. We have got the result like this. GID is there, code is there, and name. All the 3 features along with the geometry. These are displayed as a table form only. If I want to see them as a geometry, then what I need to do here, we can write it as text. Here, before the star, we can write it, select geom as text from BC underscore municipality. So I will get those values in the form of coordinates also. If I want to see them in the map, then I need to use QGIS or GVSIG or any other kind of third-party software. Similarly, if I go to the next slide, this was done. Then here, now that was one query, one table was displayed over there, and we have fetched all the records. Now I am interested in some specific queries, like what is the total length of all the roads expressed in kilometers. Now, so how to fire it? How to get the output out of these queries? This kind of query. So what I can have? Select sum length. Length is again one function. Sum is also one function. So length, the geom divided by 1000, because the units of the previous file was in meter. So I need to convert them into kilometer as km road. This is the alias name which is given to the outputs only. It is not there in the actual table, but it will be displayed as an result, as an field name for the output of my query from BC underscore road. So this will be the outcome of that query. Select sum total length. I want the length of all the rows, so I need to sum all the rows. What it will do? It will take the length of all the rows. It divide them by 1000 as kilometer from BC road. So from BC road, all the geometries, the length of geometries will be calculated, and then they will be summed, and it will be displayed like this: 70842.12 kilometers. This is the simplest query of spatial database. What I have done, I have found out the length of all the query, all the rows of the BC underscore road table. Similarly, another kind of query: how large is the city of Prince Georgia in hectare? Now, this is one special query now here. So what will the query for it? This is very interesting here. Select st underscore area, because I am interested in knowing the area of that a polygon. So st underscore area, the underscore geom is the geometry name, always it is there, divided by 10,000 as hectare. This as hectare means hectare is the name of the field of the output from BC underscore municipality, where name equal to Prince Georgia. So Prince Georgia is the name of the city in this municipality, and what is the total length, total area of that city. So it will provide me that value. How large the city of Prince Georgia in hectares? Okay. Update BC underscore municipality, set area equal to area bracket the geom slash 10,000. So these two queries, it will provide me the area of that Prince George's in hectare. Another kind of query: what is the largest municipality in the province by area? We have to name the province which has the largest area. So how to get it? Select. I am interested only in the name. st underscore area slash 10,000 as hectare from BC underscore municipality. Order by hectare descending, and then limit 1. So it will give me in the descending mode. So that value will, the topmost value will be the highest area of the municipality, which is visible over there. Now again, one is there: what is the parameter of the municipality of? Now I am interested in the parameter. So I have the function called st underscore parameter. So select st underscore parameter, the geom from BC municipality, where name equal to Vancouver. So parameter is the function over for this. One can also make use of spatial functions such as st underscore distance or intersect or contain within to narrow down the results of the spatial search. Let us take one of that one. Find the municipality within a distance from a road. I want to find a municipality which is within a distance from road. Now we can have the function called st underscore d within geometry A, geometry B, and then radius So example is over here, select distinct means unique variable, M and dot name from BC underscore road as R and BC underscore municipality from M, where ST underscore D within R dot geometry, this is the road geometry, M dot the geom, this is the municipality geometry with the distance of 200. If it is true, then only you list it. So this query will give me the this location information also, this containment queries is also fired over here. If I go to the next one, there are some more queries similar to this, like find the name of all the municipality which are the neighbor of vernacular in a BC municipality table. Now I need to know what are who are the neighbors of this Vancouver. So for that, again C1 dot name from BC municipalities, it is stored as C1 and BC underscore municipality C2, where now I am having two aliases of BC underscore municipality. First is C1, the other one is C2, where ST underscore touches, because I am interested in the neighborhood of Vancouver. So I can have it C1.geom, comma C2.geom equal to true. If they are touching each other, then and 2 dot name equal to Vancouver. So if they are touching it, and whom they are touching, Vancouver. So this way I can fire complex queries also. To perform a reprojection also we can do it, like st underscore transform this geom 4326 from geo database table. So transformation queries are also, or converting from one position system to the other position system, that is also possible through SQL queries. Viewing the querying results now, I have the QGIS. So in the QGIS here, this I need one DB plugin also for this QGIS to fire the query here itself in the QGIS and see the result. So this is the interface of the DB plugin for QGIS, database plugin actually. So here I can select that query, and once this query is fired, it is displayed as a table and as map also. It is highlighted over here, green color, yellow color over here. Similarly, if we go next one, same. This is all are the results of the query which can be displayed in this QGIS, and by using QGIS and DB plugin. DB plugin is used for firing the queries, and QGIS for displaying them. Next, if I say some overlays functions also are available, like st underscore intersect or st underscore intersection. Difference I already have told you. Intersect means this is a Boolean operator, whereas this is a geometry operator. Means output will be a intersection of the two geometry. Overlay and same way only, BC underscore municipality and BC underscore voting area. This is the total voting area, and this is the municipality area. So these all are queries only which are available in SQL for different kind of spatial operations actually. Like you can see in this one also, intersection is there. So here these two geometries will be intersected and the output will be displayed. Output geometry of intersection of these two geometries will be displayed over there. So there are many. Now one example, let us say, which has been done with the help of this spatial queries, PostgreSQL, PostgreSQL, SQL. So many things are there. So are there any applications for it? Yes, there are many applications which have been developed. One case study is like web-based GIS application for flood hazard management. So here all the table, all the spatial data which we are seeing over here, that is coming from a database table only. All this data is stored in a table and are getting displayed in this web environment using GeoServer. GeoServer I told you earlier also, it is a web-based tool which allows us to see the data in a web environment as a spatial entity. Not only as a spatial entity, it will show us the data as non-spatial entity also. Both the ways it will be able to display. One example of that one. Another is their biodiversity information system created at Indian Institute of Remote Sensing. So here, this is one analysis part we can just say. One biodiversity map is over here. This all is stored in a database table. Now I need to convert, I need one small portion of this. Suppose I want to extract the biodiversity map of this Uttarakhand state. So I will draw a polygon around it, submit the query, and output will be displayed. So all this is one example of spatial data analysis which has been already implemented in this biodiversity information system. one more example, CHS. This is Contributory Health Service Scheme Beneficiaries of IIRS, Indian Institute of Remote Sensing. So all the tables they have been storing in a database table, in a PostgreSQL table, and in the web environment we are able to fire it as a spatial, as both as spatial and non-spatial entity. Now here, one more benefit is there, like database backup and restore facility, that is also available with this PostGIS. We have to start with PGAdmin. What is PGAdmin? PGAdmin is a user interface for PostgreSQL. We showed it earlier also. So this PGAdmin, in this PGAdmin itself, we have the option called database backup. Right click on the specific database, right click on that, suppose PostgreSQL demo. We have to right click over it and select the backup option. It will be highlighted, and select the file name and press OK. So your backup will be created. Now the same backup can be restored also in using the same PostgreSQL. So here database restore. Now create a new database. How to restore it? Once a database backup has been taken, now I want to restore it. I want to take it back. Let us say some third-party person. One person has created one backup. Now I want to import this backup into my own database. How to do that one? For that, we have to create a new database first of all. Right click on that DB to restore from the backup. Select restore from the menu item and select that file and click OK. Your backup will be restored in that new database which we have just now created. So this was all about PostgreSQL and PostGIS, the very special database management system. Thank you.
Now let us take some questions that has been asked on this lecture. The first is, please explain the function like lower, round, trim and days of week with some examples. Okay, so these are the basic functions available in any database management system. Lower means, suppose I have one string in uppercase. So what it will do? It will convert that string into a lowercase. Often, many times it is required actually. Similarly, we have upper also, means some lowercase string is there. String is a lowercase, like capital letters also. So I want to convert those capital letters into a small letters or into the lowercase. So this function lower can be used for that. Similarly, round is there. Round means, example will be, say, suppose I say example round within the brackets 14.6. So what it will do? It will convert this 14.6 into 15, means it will be rounded. So here we can have the options like we want to round the numbers to some 2 decimal places or 3 decimal places. So rounding of the numbers to the nearest number. Suppose it is less than 0.5, less than 5, then it will be a left hand side. Whereas in case of it is more than 0.5, then it goes to the next number. Trim means, suppose I want to delete some extra string or extra number from a particular given value. Suppose it is 14.7222. I want to trim the last 3 decimal digits. So for that, trim function can be used. Similarly, days of week. Days of week means I have to day of week actually. So what we have to give here? We have to type the date and exact date. As a parameter, we have to pass date as a parameter to this function. What it will return? It will return a number. 0 means Sunday, 1 Monday, like that. So numbers, it will give me the day of the week, which is that day for that particular date. Now another question is how to type lat long in degree format. Slide number 39. So here, if I am seeing here, these are actually latitude and longitudes only. And the left hand side latitude and right hand side longitude with no comma. Okay, so this way we can have it latitudes and longitudes as a single within the brackets. You first type latitude and then space and then longitude. So we can type it like that way also. One more question is there? Does PostGIS useful for publishing geospatial data or just for creating database languages used? Yeah, it is not for publishing the geospatial data, rather it is for storing or creating the database.
For publishing, I need to use some other software like GeoServer or web server. GeoServer, map server or map guide, there are many. But this is PostGIS is not for publishing, it is for creating and manipulating and using it for extracting the information from that database. It is a management system, not a publishing system. One more question, only vector data set I can upload or raster also I can import. For that another option is there, that is called PG raster. So we need to use PG raster to get this raster data imported into a PostGIS. So we can, yes, we can have raster as well as vector also. Schema name is the template name of the template, which suppose some template already I have created for a table. Now same I want to use for other tables also, so we can have this template. So there are some standard templates also. This how to create database containing RS and GIS data sets. So same we can use PostGIS and we want to publish it in lane based web portal. So I can use some third party software like GeoServer. Once the data is created in the PostGIS, then I can use GeoServer and it will publish over there. What purpose of OGC used in application? OGC are the, I told you in that slides also, OGC is nothing but an open geospatial consortium, which is an international agency responsible for developing the standards. So it is not like I have some database and I am giving some field names, I am assigning some values to it. So I am using for myself only. Suppose I want to share the data, the other person is having some different kind of data. So how to sync those two kinds of data sets? So I need to follow some standards. So who will create those standards? Neither me nor that person. There can be a third party, international organization OGC, who is creating the standards. It is saying you create the data in this format so that it can be used by a large number by other people also. You can share it also. How to handle multiple geometries based data models? We have data types in PostGIS. Multi-point is there, multi-line is there, multi-polygon is there. So they will store multi-geometry also. These data types are there, available over there. Already one question is there, what about the raster data provision in the PostGIS? So I told you PG raster is that extension which can be used for importing raster data in PostGIS. What is that digit stand for? Like what is that digit stand for, which shows in the bracket easy point number in one of the slide? Okay, you are talking about this. Let me say. So digits are actually these two digits. This is not a single digit. This is one coordinate, the x coordinate, y coordinate, and this is that x code. These two are the coordinates actually, which shown in the bracket. The two numbers. This is not a single digit. These are two numbers actually. There are two numbers which represent the coordinates. First is the y coordinate and the x coordinate. Explain longitude, latitude, degree, varchar, float, and boolean. Okay, the varchar. Varchar means it is the type of the data. Suppose the value of the data can be a string, it can be a name, or it is the name of the street, name of the person. If it is some sort of string or a character or a description, then how to store it? So this is a data type which will store that kind of values, like names is there, strings are there, description is there. But if I have some numbers or the decimal point numbers, then I cannot store those numbers in a varchar variable. I need a different data type for it. That will be a float data type. In the float data type, I can store the decimal numbers also. These two are the data types actually, where we store different kinds of data. String, varchar, numbers, decimal numbers to be specific, float, and if the values are like yes and no kind of answers, then boolean is there. Lat long degrees, these are also degree data type only, but it will come under this float only. How to type lat long in degree format? Simply degree format. So you can have it separated by the space within the brackets. First type latitude, space, then longitude. As directly as a degree only. Numbers are there, no need of specifying that symbol for the degree, just type the numbers and that reference system will take care of the part of it also, whether it is in meters or it is in degrees. What Boolean function signifies, slide 38. Boolean functions mean the value, if the value is either true or false, only two values are there, true or false, then this is the data type which store the variables which have only two kinds of data sets, the data values true or false. Please explain the commit and rollback operation in DBMS. Okay. Commit operations means, suppose one transactions you have performed, update operation, you want to change the, you have to change, you have changed some data, or you have inserted some values into a database, and you want it to be a permanently saved in the database, then we use this operation called commit. Whereas rollback means, suppose some 2-3 operations you have performed, inserting a data into it, updating the data, and you want to undo it, change it. Undo means you want to change it to the previous stage. Then this rollback operation is performed there. Okay, I think I have covered most of the questions. So let me finish it over here. Thank you very much.